बाय बच्चा।
Hello everyone. Good morning. How is everyone? कैसे हो आप सभी? I hope everyone is good and having great morning. है ना? Everyone done with breakfast? Yeah, some of you escaped simply because you didn't like what was there in your meal. Okay, so what we are going to do in the today's class, as I said yesterday, so today in the class we will be largely discussing that is Ampere circuital law, and it's very important for solving some good questions, and question also come from this portion. So let's go through it. So आज के class के लिए that dipole concept I removed, that I will discuss in the next weekend classes. Okay. So magnetic field due to current carrying wire we discussed largely in the previous class. Sorry, in the previous class. And in today's class, we will be solving more 1 or 2 questions and also one more concept we will look at. And then we will largely discuss what Ampere circuital law. Okay. Chalo. So if we go through a quick recap of what we studied in the previous class. So सबसे पहले था field due to circular loop at its center. Just through formulas I am going. So if current I is flowing through a circular wire, what will be magnetic field at the center? Magnetic field at the center formula will be V equal to mu naught I by 2R. R is the radius of the circle. And how you will calculate the or find out the direction of magnetic field here? So if current is flowing in a loop, कोई भी loop हो, be it a triangular loop, be it a circular loop, be it a square loop, whatever kind of loop it is, to find the direction of magnetic field, what you have to do, you simply take your right hand, curl your finger in the direction of magnetic field. So curl like here, and thumb will give you the direction of magnetic field. So here, thumb will go inward. So magnetic field at the center is inward. Right? So to calculate, to find out the direction of magnetic field, we need to use right hand. If current is flowing through loop, you need to curl your finger, thumb will give you the direction. And if current is flowing in a straight wire, like पहले तो arc को देख लेते. So if there is an arc and the current I is flowing through it, and this arc is making an angle theta at the center. So how much will be the value of magnetic field due to this arc at the center? What it will be like we used unitary method for it, and it was theta by 2 pi, right? So this is the formula. Again, direction we can calculate the way we calculated before. Now, in case of a straight wire, if we talk about direction, then if current is flowing in a straight wire, then in the direction of magnetic field, now we need to keep our thumb. Now, curling of finger will give us the direction of magnetic field. So here magnetic field will be in this sense. And if we go on calculating magnetic field at point P, at certain point, if we have to calculate, जैसे यहाँ पे, if you have to talk about the shape of magnetic field, so it will be circular. But if you have to talk about direction of magnetic field at point P, what it will be? So simple है, thumb को current के direction में put करो and see your 4 fingers. So here the 4 fingers is going in, and this side it is coming out. So if I call this side A, this side B, then On side A, magnetic field is going to be what? Inward. And on side B, magnetic field is going to be outward. जब भी मैं ये try कर रही हूँ, like when I'm showing you how to do it, you should also try doing it. कि take a pen and assume that current is flowing in the upward direction of your pen. Put your thumb in the direction of current. See your four fingers, A side. On the A side, these four fingers are going inward, and on the B side, four fingers are going outwards. So here, towards A side, at any point, magnetic field will be inward, and on B side, at any point, magnetic field will be out. Then this was the thing, right? Now, what is the magnetic field formula here? So it will be mu naught I by 2 pi d. I hope formula मैंने गलत नहीं लिखा ना? नहीं, done. So mu naught I by 4 pi d into sine theta 1 plus sine theta 2, where theta 1 and theta 2 are what? This is your theta 1 and this is your theta 2. Then why this is theta 1, this is theta 2? Why not this one theta 1 and this one theta 2? Because just see the current is flowing from where to where. So current is flowing from A dash point to B dash point. So start measuring angle first from A dash side. So first angle from A dash side you will get theta 1. Then so that is why this is theta 1. I also told you in the previous class how you will use the sign convention for measurement of angle. So for measurement of angle, what is the reference line? Reference line was this. So from this line, if you're going in clockwise direction, you will tell angle is positive. If from this line you're going in anti-clockwise direction, you will say angle is negative. जैसे यहाँ से अगर इस direction में जाओगे, that is anti-clockwise direction. So to measure theta 1, we need to go like this. So that is why theta 1 was taken with proper sign convention as minus theta 1, right? And theta 2, if you're going to measure from this line, it is in clockwise direction. So that is why with proper sign convention, theta 2 will be plus theta 2, right? So ये हमने कल देखा. This is the formula. अब देखो ये तो क्वेश्चन है, इसमें हमने बहुत सारी और भी चीजें देखी थी. एक था तुम्हारा, if the wire is infinitely long, if wire is infinite on both sides, on both ends, I must say, in that case, what was happening? In that case, if the wire is your infinitely long, then what will happen? In that case, theta 1 equal to theta 2 equal to 90 degree, and magnetic field will become how much? Mu naught I by 4 pi d. Again, I talked about semi-infinite wire. Then that formula was also there. And one important thing I told you is if current is flowing in a wire like this, and if we have to calculate magnetic field at any point collinear with the wire, at any point collinear with the wire, then at this point magnetic field is going to be 0. Even if you're taking the point here, if you're taking point along the line of wire, magnetic field at that point will be what? 0. And it was 0 because from the Biot-Savart law, जो कि magnetic field का formula क्या, magnetic field के formula में क्या आता है? dl cross r. So I discussed those things yesterday. This thing you need to remember. Now, just to make sure you remember all the things, let me know what will be the answer of this question. Okay? After that, we will move ahead. So take some 2 minutes of your time and let me know what is the answer. Okay? चलो फास्ट कैलकुलेट करो सभी लोग. जेनवी सांगली, कल कहाँ थे तुम लोग? जेनवी दाहोद, you were not Jenvi Simuga, not yesterday you were there in the class, right? Yes. Can you let me know the region? Jenvi Anand, Jenvi Bharuch, Bhandara, you people were not there in the yesterday class. Try to be regular. क्या करते हो तुम लोग seriously? Being a student is your duty to attend classes. If you think you're getting benefited, you must join class. If you think you're not getting benefited, then obviously it's your decision. Then you should, you are free to decide. But sometimes at this age, we need someone else suggestion. Also, we need to hear to people, right? अच्छा, parents meeting था कल, हाँ था. In many Navodayas it was happening. So okay, but there were many people from many Navodayas, no? Was it not happening there? Anyway, देखो एक चीज मैं बताऊं, if you are sincere about your classes ना, your management will also think about arranging your classes. They will also think about managing things in such a way that your class will not get hampered. So just show that interest. It's also very much required. Sometimes I know you people are helpless, but I'm just saying कि try doing that. ठीक है? चलो, answers please. You have to calculate magnetic field at the point O. What is the structure given here? Structure looks something like this, ना? कुछ ऐसा है. Something like this, right? And current is flowing in this sense. And because of this, we have to calculate magnetic field at this point. And this angle is given, right? This angle is how much? 45 degrees. Now calculate magnetic field because of these four portions through which current is flowing, right? Four portions कौन सा हुआ? एक ये arc हुआ, this one straight line, this one arc, this one straight line. So let me know what answers you're getting. Do solve. You all must be knowing mu naught by 4 pi can be taken as what? 10 to the power minus 7. Okay? So put the value and let me know the answer. Yes, here on YouTube also. Let me know. No answers? Seriously, you people are not listening to me, I guess. कुछ भी रिवीजन नहीं कर रहे तुम लोग, क्या कर रहे हो? Come on, yeah, let me know. Even one or two answers. Even one, like no answers have received 8. Okay, anyway, ठीक है, मत करो तुम लोग, मैं ही कर लेती हूँ. I'm going to give exam again, G Mains and G Advanced. No worries, I will do. So what the question is, यहाँ पे 4 arcs है, so magnetic field at this point, because of these straight wires will be 0. Because of these two straight wires, it is going to be 0. Why is 0? क्योंकि you just see this point is lying along the line of this wire, right? So if a point lie along the length of wire, magnetic field because of that wire at that point used to be what? 0. Just now we have seen that, है ना? So magnetic field because of this portion, call it 1, call it 2. So magnetic field because of one portion is 0, and also because of two portion is 0, because the point O is lying along the line of these two wires. Done. Now we have another 2 arcs. So one is this, let's call it 3 and let's call it 4. First calculate the direction. So in case of third, current is flowing in this direction, right? So since current is flowing in a circular arc, how we will calculate the magnetic field? We need to curl our fingers in the direction of what? In the direction of magnetic sorry, in the direction of current. So if you assume it's something like this, ऐसे कर लो, अगर निकालने में problem हो रही है तो just do one thing. If current is flowing like this, it means current is flowing in which sense? Clockwise or anti-clockwise. If current flows anti-clockwise, magnetic field is outward. If current flows clockwise, magnetic field is inward. So because of this, magnetic field will be what? This is what? This is clockwise. So magnetic field will be what? Inward. So B3 का direction क्या मिलने वाला है मुझे? Inward. And what about B4? Here the current is going in which sense? It is going in anti-clockwise sense. If current is going in anti-clockwise sense, my finger thumb is pointing outward. So magnetic field because of B4 is going to be in which sense? Outward. So this is out. Now net magnetic field will be at point O will be what? Either B3 minus B4 or B4 minus B3 depending on the magnitude, right? So let's calculate it. What will be the value of B3 or B4? Let's say B4 का value क्या होगा? So mu naught I by 2R. Radius कितना है इस arc का? Just see the radius of this arc. That is 3 centimeter. अभी के लिए मैं R1 ले लेती हूँ. ठीक है, mu naught I by 2R1. How much angle it is making at the center? तो चलो उसको भी अभी theta लेती हूँ मैं. Theta by 2 pi. Done. And net magnetic field I am going to calculate. Yes, Jane B. Warangal model. Are you the model? You know what are the requirement to become the model? They need a high level of work dedication and at the same time high level of confidence. If you are having enough of these two, please do go for that. I will be really happy to see some of you doing modeling. I really want diversity in class. I will support also. चलो ठीक है. So B net तुम्हारा क्या होने वाला है? Mu naught I by 2R1 into theta by 2 pi minus क्या करोगे? Calculate B3. So that is mu naught I by 2R2. Again angle they are making same at the center, 45 degree 2 pi. So what will be the answer? Answer will be, take common things outside, mu naught I by 4 pi and here what it is? It is theta, right? And 1 by R1 minus 1 by R2. Okay. So this is all. Now what will happen? Mu naught by 4 pi को आप लिख लो, that is 10 to the power minus 7 into current का value आप लिख लो. Current is 10 ampere. So this is current. And what is theta? Theta is going to be pi by 4, right? And 1 by R1 minus 1 by R2, that is 1 by 3 minus 1 by 5, right? 1 by 3 minus 1 by 5. So do this thing now, calculate it, and what answers you're getting, let me know. Okay, let me know what answers you're getting now. Jaldi se fast batao. This is in centimeter, right? So convert it into meter. If you're going to convert it into meter, 10 to the power 2 additional you will be getting. So now let me know the answer. Yes, come on, let me know. And one more important thing I want to say, those who have written their name something like King of World or Model or something like that, please change your name to something very much decent. It should not happen in your classes, right? And in the class, you're not answering, not giving responses, but you are very quick to turn on your videos and then comb your hand through your hairs. This should not happen in the class, and I won't entertain it, I'm telling you. I talked about I support diversity doesn't mean I support all such kind of wickedness in the class, right? This should not happen. Listen to me very carefully. It's an online class. It doesn't mean you will do whatever you wish like, right? Please try to respect what you are getting. Understand? And if it is not getting across your head, I know how to deal with things. Okay, let me know the answer. Okay, one answer I got, that is correct. Okay, thank you. Chalo, okay, let's move ahead. There is no point of staying here. I have understood you people's behavior and nature. What you can do, I have understood. Chalo, okay. It is a huge disappointment. Seriously, being a student of class 12, you have already crossed 6 months of your classes and everything, and still your attitude is this. Seriously, you're going to write exams after 3 or 4 months. What sort of seriousness you're carrying to the classes? What is this attitude, really? Anyway, I don't want to take harm those students who are really sincere. I don't care. Okay, so what's the magnetic field here? जैसे यहाँ पे मैंने एक बहुत ही important example लिया है. अभी तक हमने क्या देखा था? Till now we have seen that this was the wire and we were taking point inside, like in front of the wire somewhere, like within this region we were taking the points, right? If our point lies beyond this region, suppose I'm taking points somewhere here, and here I have to calculate magnetic field because of this wire. How will I do? Just say here it's very easy, like I will connect it like this, I will connect it like this, then draw perpendicular from this line like this. Done. This is the current flowing. We will call it theta 1, theta 2, and we will put the formula mu naught I by 4 pi t sine theta 1 plus sine theta 2. Again, even if the point is somewhere here, what we will do? We will draw a line from here to here. Again, draw perpendicular like this. We will call it theta 1, call it theta 2. Put in the formula, get the answer, right? But what difference is going to happen here if you are going to calculate magnetic field at point P? क्या होगा बताओ? तो यहाँ पे क्या करोगे? सबसे पहले तो first step is what? Join two ends of the wire to the point P. तो अगर मैं join करूँ, if I'm going to do, this is something like this. Done. So this is this. Now, how we will draw the perpendicular? That's the question. So don't worry about that. Just imagine, imaginary line you create. Just imagine that this wire is extending like this. So you have to simply extend it and then draw perpendicular on this. So this will be the distance D. Now, what will be the angle? Angle measurement always happen by taking this line as the reference, right? So अभी भी आपको यहीं से measure करना है. This will be your angle theta 1 and this will be your angle theta 2. This will be your angle theta 1 and this will be your angle theta 2. But now look at carefully what is happening here. Both the angles were measuring in clockwise direction. So by sign convention, both the angles will have sign as plus theta 1 and plus theta 2. So this is very important. If question is coming like this, you should able to understand कि साइन कन्वेंशन क्या होगा. ठीक है, तो यहाँ पे देखो, इसलिए मैंने इसको अलग से लिख ही दिया है. म्यू नॉट बाई 4 पाई I by a theta 2 theta 1. तो अगर आप यहाँ वैल्यू पुट करोगे sin theta 2 minus sin theta 1. So this is going to be the formula, right? Earlier what was happening? Earlier formula was sin theta 1 plus sin theta 2. When point P is lying somewhere in this region, but if it is going beyond that region, then in the formula there will be term sin theta 2 minus sin theta. Okay? So I hope you will keep this in your head. This is important. Chalo. Now the most important thing that we are going to discuss is Ampere's circuital law, just like we discussed Gauss's law in your what? Gauss's law we learned in that is called electrostat. है ना, ये काफी important था for calculation of electric field. At the same time, this is very important for the calculation of magnetic field for various symmetrical structures again, right? तो यहाँ पे देखो ये expression है क्या? जैसे गॉस लॉ का expression क्या था? E dot ds equal to q enclosed by epsilon naught. And here it is B dot dl. Here it was area vector and here it is length vector, right? So B dot dl equal to mu naught is getting replaced here, like here 1 by epsilon naught is getting replaced by mu naught, and in place of charge here there is current. Because charge produces electric field, here current is producing magnetic field. So there is quite a similarity between these two. Difference being here we take area vector and here we take length vector. अब देखो पहले तो एक्सप्रेशन को समझ लो, एक्सप्रेशन क्या है, B dot dl इक्वल टू म्यू नॉट I इनक्लोज. फॉर अ मोमेंट लेट्स फॉरगेट कि इसको अप्लाई कैसे करना है, पहले एक्सप्रेशन को समझते हैं, ठीक है? तो वेरी फर्स्ट थिंग इज कि एम्पियर लूप इज 2D लूप. जैसे टू अप्लाई द गॉसेस लॉ वी यूज टू टेक गॉसियन सरफेस, है ना, वी यूज टू टेक गॉसियन सरफेस, राइट? Also, to apply ampere circuital law, we need to take ampere loop. An ampere loop will be 2D loop. Gaussian surface used to be 3D, right? And it will be what? 2D. ये क्या होने वाला है? 2D होगा, ठीक है? Now, how we will select the loop? Loop selection कैसे करना है? तो we will choose loop that matches with the shape of magnetic field. हाउ टू अंडरस्टैंड इट, जैसे अभी भी देखो, अगर मेरे पास एक स्ट्रेट वायर है, देयर इज अ स्ट्रेट वायर इनफाइनाइटली लॉन्ग, एंड इफ आई हैव टू कैलकुलेट मैग्नेटिक फील्ड बिकॉज ऑफ इट एट डिस्टेंस d, if I am going to apply the ampere circuital law, first thing what I will do, I will choose a loop. loop कौन सा लेना है? 2D. और 2D loop कैसे लेंगे? What are the methods? How we will select it? So first try to see what is the shape of magnetic field. So if current is flowing in a straight wire, what will be the direction of magnetic field? How we will calculate it? So in the direction of current we will place thumb, we will curl our finger, curling of finger will give us magnetic field. So here in this case magnetic field shape is what? Circular, है ना? magnetic field shape is what? Circular. So here I have said that choose loop that matches with the shape of magnetic. So here ampere loop कैसा लेना होगा मुझे? Circular. Done. So how we will select ampere loop? By looking at the shape of magnetic field. If magnetic field is circular, ampere loop will be circular. If magnetic field is not circular, if it is a straight line, जैसा कि आप लोगों ने पढ़ा होगा solenoid में. So in case of solenoid, you must have seen कि magnetic field inside solenoid by all those assumptions, even a straight line like this, है ना? So if magnetic field is a straight line, ampere loop will be either a square ले लो, ampere loop either square होगा या sorry this is rectangle, या फिर square ले लो, कुछ भी लो, but it won't be circular. It will match with the shape of magnetic field. So if magnetic field is straight, magnetic field is getting denoted by straight line, ampere loops would be either rectangle or square. तो ये आगे हम लोग करेंगे भी. If the field line is circular, ampere loop will be circular. If the field line is a straight line, ampere loop will be rectangular or square. चलो मैं एक करके दिखाती हूँ. जैसे अभी अभी हमने लिया था, क्या लिया था हमने? So हमारे पास एक straight wire है, done, and we have to calculate magnetic field at distance d, done. So what will be the magnetic field at this point? Again, if this wire is not infinitely long, if it is not, then what will happen? Then we can't say magnetic field will be this of this shape at this fringes also. Okay, there will be certain kind of fringe effects and all that you have studied again in electrostat also. I have taught it, fringe effect and capacitor, same thing. Just here, if the straight wire is not infinitely long, then we can't say the magnetic field everywhere will be circular like this. Then it will get affected or its shape will change somewhat. You just think like that. So if the wire is infinitely long, we can say that the magnetic field shape at every point we can take as this circular, right? So if it is like this and you have to calculate magnetic field at point P, how will you apply the ampere circuital law? So यहाँ पे ध्यान से देखो, B dot dl equal to क्या होता है? Mu naught I enclosed again. So first thing that we need to do is, first thing we need to see is if the loop is sorry, what is the shape of magnetic field? So here the shape of magnetic field is what? shape of magnetic field is circular. So ampere loop will be what? Circular. First thing. Second thing, we have to calculate magnetic field at what distance from wire? At distance d. So if ampere loop is circular, then draw a circle of radius d. ठीक है? तो यहाँ पे हमने draw कर दिया. Done. Now what we have to do? We have to calculate B dot dl. Now you can see here, there will be magnetic field. Shape is also this. This is also ampere loop. So at any point, if you're going to take, suppose I'm taking here dl length. So this dl length and magnetic field at this point will be tangential to this dl length. So angle between B and dl will be what? Angle between B and dl is going to be what? 0 degree or what? होगा या नहीं होगा ये बताओ. समझ पा रहे हो या नहीं? That's important. Are you able to understand? मैं directly question put कर सकती थी, but I'm explaining so that you can solve question more conceptually or by understanding it. What will be the angle between B and DL in this amperial loop? Let me know through the in the chat section. तुम लोग गुस्सा दिलाकर अच्छा नहीं किए, मेरा मूड खराब हो गया सीरियसली. Should not do such thing in the class. मैं क्या बोलूं? You changed my energy. You changed my enthusiasm with which I started the class. Yes, let me know what answers you are getting. मैं पूछ रही हूँ angle between B and DL will be what in this amperian loop. I just want to understand if you are able to get it or not. That's my concern, nothing else. Let me know. Okay, ठीक है. चेन बी सिमुका 90 डिग्री. अच्छा 90 दिख रहा है. ओके. चेन बी सांगली 90 दिख रहा है. ओके ठीक है, सबको 90 दिख रहा है. तो 90 है नहीं, 0 है. 90 क्यों दिख रहा है वो मैं देखती हूँ. यहाँ पे देखो वायर ऐसा है. डन. दिस इज द वायर. दिस इज इन्फिनिटली लॉन्ग. at any point D or at any point P at distance D, we have to calculate what? Magnetic field. Yes, Kaushik, what happened? So at this point, we have to calculate magnetic field. Now, how we will do this? So to apply ampere circuital law, first we need to choose ampere loop. Ampere loop will match the shape of magnetic field. So for a straight wire, magnetic field shape used to be what? Circular. I have explained it time and again. So circular. तो मुझे जो ampere loop लेना है वो भी क्या होगा? Circular. So draw a circle at point P. You have to calculate magnetic field, right? So draw a circle passing through point P with wire at the center. So this is the circle, this is the center. Center will lie on the wire itself, right? So this is done. Now we have chosen ampere loop. Now we need to calculate these things, right? So we need to calculate B dot dl. Now I'm taking any length dl here, okay? Any length dl here. So this is dl. And at this point, what will be the magnetic field? At this point, I have taken a small length element dl. So at this point itself, I'm asking what will be the magnetic field direction. So magnetic field is also circular now. So this is also the direction of magnetic field. So at this point, magnetic field will be along the tangent. Done. So this is magnetic field direction. And this is also dl. dl is also this line now. So angle between B and DL is what? Is it 90 degree or 0 degree? Let me know now. Is it 90 degree or 0 degree? Yes. Is it 0 degree or 90 degree? What you say? Jaldi se batao yaar. You just need to click on 0 or 90, something like that. And if you're not able to understand that, also let me know. Okay, chalo, koi answers nahi. And anyway, I will move ahead then. So BDL के बीच का angle is 0 degree. So here we will write BDL cos 0 equal to mu naught I enclose is what? Current passing through this, or current that is going through this loop. So loop is this, ampere loop is this, and through this loop, how much current is going out? This is the current I. है ना? If I current is passing through the loop, then I enclosed will be what? I itself. So यहाँ पे I लिखो. Now P dl cos 0 is 1, that is equal to mu naught I. Now, what is this B? Is this B a constant or what? Just you see here, every point on this loop, if you take any point on this loop, that point is at what distance from the wire? That is a distance B. So every point is equidistant from the wire. And every point on the loop is equidistant from the wire. It means at each point on the wire, magnetic field will be same because they are at same distance from the wire. Done. So magnetic field at each point, if we have taken DL here, magnetic field will be something B. Even if we are taking DL here also magnetic field magnitude will be the same, right? Because this length element is also at the same distance from the wire, that is B. So B is constant. So constant ko bahar le lo, DL mu naught I. Now what is this sigma DL? This sigma means summation of all small lengths. So summation of all small lengths means summation of all small length of this Amperian loop means perimeter of this circle, right? So that is equal to B into 2 pi R, that is 2 pi D mu naught I. So B equal to mu naught I by 2 pi D, right? So this is the magnetic field formula we have calculated also from the straight wire formula, for infinitely long wire, and we were getting this only now. So by using Ampere law also we can calculate. But we can't use Ampere law for finite length of wire. क्यों? क्योंकि यहाँ पे magnetic field same will not remain uniform throughout. That is why, okay, we are not able to use this for this, but we can use it for the infinitely long wire. That's now do this question if you have understood it. I don't know. Because you people don't reply whenever like I ask for doubts. Very little you reply. Then so I'm giving you again 2.5 minutes and try solving it and let me know the answer. Okay. JNB Simoka. Not actually. You need to recheck. सही से calculation करो. Use Ampere circuital law, the one we discussed just now, and apply it. क्या है? Cylindrical conductor है. So this cylinder must be a solid cylinder, right? Cylindrical conductor of radius R is carrying constant current. ठीक है? Plot of magnetic field you have to draw. Okay. JNB Simoga. Okay, done. So you have to plot magnetic field as a function of distance d from the center of the wire, right? So jaldi se batao. Okay, this. Okay, who is this Narendra Modi? Just let me know, huh? Such activities is not going to give you anything, my dear. Anything. You're fooling yourself, you know. If you don't understand meaning of what should be written there, it's really a miserable situation you're living in. You are very poor. पता है, धन से नहीं, दिमाग से, वेरी मच पुअर। और ये अमीरी पता है कब आती है? खुद से आती है। No one can make you rich by mind, you know, that depends on you. Really, I'm feeling very bad for you people. I'm feeling bad because you don't have this much sense in what to write where, what to do where. Seriously. Sorry for you, seriously. Genvi Sangli. Okay, that's not correct. Second portion of your graph is correct. Just focus on the first portion. ठीक है? एक बार देखो. Yes, others, please do solve it. This thing is also in your NCERT example question, if you remember, if you go through books. Admin, yes, that's true. Others, on YouTube, I'm not getting any answers. क्या हो गया? सभी शांत क्यों बैठे हो? Computer lab. Okay, okay. You're from which NV? Answer is correct. Chalo. If you're sitting here for 1 hour, we should use this time like some people are using the way. ठीक है? JNV coach. Okay, thank you. Be sincere, be sensible on the top of everything. ठीक है? ये सेंस ना खुद से आता है. Please try to have it यार. क्या कर रहे हो तुम लोग? Seriously. A cylindrical conductor of radius r. एक हमारे पास cylindrical conductor है and this is of radius r. Done. So this is like this. Over. And what is happening? This is carrying a constant current. So current must be flowing like this throughout and coming out like this, right? So I amount of current is flowing, suppose. Now the plot of magnitude of magnetic field B with distance D from the center of conductor is represented as what? तो कैसे निकालेंगे? Suppose कर लो, सबसे पहले let's take a point that is not outside the cylinder, that is inside. So at this point, I'm going to calculate magnetic field first. How I will do that? I can use Ampere circuital law, right? So what is that law? B dot dl equal to mu naught I. First, I need to identify Ampere loop. Loop कैसा होगा? Again, देखो ये cylinder है, तो पेन को अगर तुम्हारे हाथ में पेन है, you can see that it's also in the shape of cylinder. So again, we will use the same rule that we have used for straight wire, right? So current is flowing in the upward direction. Magnetic field will be what? Along the curling of finger. If curling of finger is giving the direction of magnetic field, it means magnetic field is what? Circular, right? So Ampere loop हम यहाँ पे क्या लेने वाले हैं? Circular. First thing is sorted, right? Now, so at this point, if I'm calculating magnetic field, so draw a circle of this radius. ठीक है, तो मैंने बना लिया. Now, I need to calculate what is current enclosed in this Ampere loop. So I have made also a cylinder kind of. मतलब मेरा जो Ampere loop है वो कुछ ऐसा है. Then circular है, मान लो, कुछ भी मानो. So यहाँ से how much current will go out? This much. Done. So whole current, जैसे ये पूरे cross section से current जा रहा है, this much, and my Ampere loop is smaller than this cross section, this one. So through this, how much current will flow? That's the question now. So if I current is flowing through how much cross section? Pi r square. If r is the radius of this cylindrical wire, done. So through pi r square cross section, I current is flowing through unit cross section. How much current will flow? This much. And just calculate the cross section of your Ampere loop. If its radius is a small r, then through this cross section, how much current will flow? I by pi r square into pi r square, this much, right? So इसको current density चलो लेकर चलते, J लिखते हैं इसको, done. Now let's calculate it. So BDL again cos 0 होगा क्योंकि my ampere loop is of the same shape as that of magnetic field. इसलिए B और DL के बीच का एंगल क्या होने वाला है, 0 डिग्री, like this. Mu naught I का वैल्यू J into pi r square, right? Now, if we are going to see B is constant, take P outside, cos 0, 1 DL. This is equal to mu naught J pi r square, right? And DL, summation of DL will be what? B into 2 pi r. This is equal to mu naught J pi r square. If you are going to see it, so B will be equal to what? Mu naught J pi by 2 pi. एक r से एक r कैंसिल होगा, यहाँ पे r बचेगा. So this is constant, right? So B is directly proportional to r if r point is lying inside the cylinder, right? So for inside, B is directly proportional to r. It means graph will be what? A straight line, right? So initially graph is a straight line. तो यहाँ पे देख लो, B constant नहीं रहेगा, B will change with r, but proportionately it will change. So a straight line curve starting from the origin, either this can be true or this can be true. Now let's see for outside point. अगर आप outside point के लिए calculate करोगे, take a point P here. So ampere loop again circular, but of this radius. Again small r इसको समझते हैं, variable लेते हैं. So again B dot dl करोगे, है ना? Angle will be again 0 degree. So B dl, this is mu naught I. Current flowing through this cross section will be what? Whatever is flowing through this conductor, same. So I, now B is constant, B को बाहर ले लो, DL क्या हो जाएगा? 2 pi r equal to mu naught I. So B is inversely proportional to r. If B is inversely proportional to r, my graph will go something like this, right? So correct answer should not be this. यहाँ पे graph देखो, for r, for D greater than R, it is a straight line like this constant, but it's not like that. It's like this. So this is correct. I hope it is clear. Chalo, I hope till now you have understood how to apply it. तो यहाँ पे भी apply करके दिखाओ कैसे होगा. Done. Take your time. Do solve it. Do solve it. Because if you have learned something, you should know how to apply it, right? So do solve it. Take your time and let me know the answer. I'm giving you 3 minutes. ठीक है, तो मुझे आंसर्स बताओ क्या आएगा. जेनवी शिमोगा, ध्यान से देखो यार, r/2 डिस्टेंस से पहले how magnetic field will be like this, the way you have answered. ध्यान से देखो, क्वेश्चन क्या है? This is a hollow conducting cylinder, right? This is not solid cylinder. This is a hollow conducting cylinder, and this hollow conducting cylinder has inner radius of r by 2 and outer radius r. Done. So it is something like this. I mean, if this is r and if this is r by 2, okay, let me draw it more clearly. So if this is r by 2, done. So what is the case? This is a hollow conducting cylinder, but this is filled, right? Okay, this is a hollow conducting cylinder of inner radius r by 2, outer radius r. It means in this region there is nothing. This is vacuum, right? And between r by 2 and r, there is something, and current must be flowing through that length itself, right? So this it can't pass because it's vacuum. It's insulator. If vacuum means insulator, right? Think carefully, do it. You will be able to do it if you apply things the way I have told. Choose ampere loop, calculate B dot DL, calculate I enclosed. That is more important here. I know B dot DL is very simple, the way we have done earlier, right? One more minute I am giving. ओके एडमिन देखो तुम्हारा 0 से r by 2 तक तो सही है and also from r to small r it's correct but between r by 2 to r you have done mistake. चलो देखते हैं ठीक है. So what's the question now? This is I said just now from if we call it r equal to 0 line, then from r equal to 0 to r by 2 what will be the case? Just give me 1 second. Okay, so Jinvi Shimoga. Again, same mistake you have done also. So if this is r by r equal to 0 and this is r equal to r by 2. So if we take any point in between these two, suppose I'm taking a point here. So here SA, something like this. And if I'm going to apply Ampere circuital law through this, B dot DL equal to mu naught I enclosed. So current flowing through this cross section, this Amperian loop will be what? It will be 0 because this is the hollow region, right? Current is only flowing through this solid region. Done. So here I enclosed is 0. It means B will be 0. So B is 0 from R equal to 0 to R by 2. Done. That is over. Again, I have taken Ampere loop as a circular because now I don't need to discuss time and again. Current is flowing through a cylindrical wire kind of thing. So shape of magnetic field will be what? Circular. That is why Ampere loop I have taken as circular, right? Now let's take another point between R equal to R by 2 to R. Okay? So this is R and this is what? R by 2. Done. So if I'm taking a point here, somewhere here. So again, suppose कर लो ये distance को smaller variable ले रही हूँ. So Ampere loop will be of this radius, right? Now what we need to do, again we need to do the same thing, B dot dl equal to mu naught I enclosed. So calculate current flowing through this cross section. ठीक है, so what will be current flowing through this cross section? तो सबसे पहले वो निकालने के लिए you just understand what is the current density here. ठीक है, so current is flowing through which cross section? Through this cross section, right? Through this cross section. So what is this? This is equal to pi r square minus pi r square by 4, है ना, क्योंकि this whole is pi r square, this whole is pi r square, and this is pi r square by 4. So through what cross section current is actually flowing? Minus of these two. So this is this. What will be the current density if you are going to calculate? So current density J will be current per unit cross section, that is here 3 pi r square by 4. तो इसको मैं J लेकर चलूंगी अब, ठीक है. Now what is the current flowing through this cross section? मतलब through Amperian loop. So what portion of Amperian loop is lying inside the solid region? That's the question ना. तो वो देख लो कितना current flow होगा. Just try to calculate it. So how much, through how much cross section current will actually flow? So सबसे पहले area निकाल लो. तो area कितना होगा? Pi, अगर ये distance मैंने small r लिया है, so pi r square minus how much you will do? Pi r square by 4. Done. Means pi r square by 4 we need to remove, because through pi r square by 4 no current is flowing. This is a hollow region. Done. So subtract pi r square by 4 from whatever area cross section your Ampere loop is having, right? So this is this is this, right? So what will be the current flowing, current enclosed current density into cross section through which current is allowed to fall. So allowed to flow, pi r square by 4. So this is the current enclosed. Now if you are going to calculate things, B dot dl जल्दी से calculate करो. तो क्या होगा? B को बाहर ले लो, dl क्या हो जाएगा? 2 pi r mu naught I will be this J. So pi r square is variable and this is constant. मैं इसको मैं k ले ले. ठीक है, तो देखो b क्या दिख रहा है मुझे? 2 pi r square. So यहाँ से इसको इधर लेकर जाओगे. If you are going to see, b is not directly proportional to r. Clear है? And here in the options, b is constant from r by 2 to r. This is wrong. Here also it is constant. This is wrong. And here b is directly proportional to r. This is wrong. And here b is not directly proportional to r, not constant. Only this is the option. So this is correct. For ahead also you can calculate like that. Done. So correct option will be B. Okay. I hope it is clear. We are running out of time. So in the next class, I will start with that is your magnetic dipoles. Magnetic dipoles because of current flowing in loops, and also we will read bar magnets. Okay. So next class में and next class में मैं बिल्कुल slow नहीं होने वाली हूँ. Let me inform you right now. Each week I slowed down because you said you have not studied, but now it is on you to revise through things, to go through things. In the next class, I will be a bit more fast. Again, that doesn't mean I won't deliver concept. I will deliver concept, but I won't wait this much for you people if you're not giving your input. Okay, done. So let's meet in the next class and also in the weekdays classes. Tab tak ke liye, tata, bye bye, take care, and take care of your mental health. Like in many more ways I'm saying. Anyway, I don't have time to discuss much. Take care, bye bye. अच्छे से रहो, अच्छे से पढ़ाई करो, and don't worry. और मेरी बात